Well, welcome back. We've got a mouthful for you tonight. Tonight we're going to focus on using sample data to estimate a population characteristic. So we're first going to begin with just some definitions. What is a population? Well, a population, kind of like it sounds, is the entire set of data. And what is a sample? Again, kind of how it sounds. A sample is a part of the population from which the data is gathered. For example, Mr. Gallagher is interested in determining the average number of days a student is absent. What would the population be? I would say our whole population would be all the students enrolled in our school. What would the sample be? The sample would be, maybe he only recorded the attendance of our math class. So instead of the entire school, he's just using one class. So I would say that's the main difference between a population and a sample. Again, population is referring to all or everybody, whereas sample is just a small part of them. So example 1, a team of scientists want to determine the average length and weight of fish in Lake Lucerne. Name a sample that could be used to help answer their question. So notice they said sample. I'm really not testing all of the fish. I just need to come up with a sample of them. How might I get this sample? Well, I think there's lots of different things. One might be spend one day catching fish and just recording their length and weight. So again, I haven't caught all the fish in the lake. I'm just taking a sample. I'm just going to catch one day of fish, spend one day, and record their length and weight. B, golf balls from different manufacturers are tested to determine which brand travels the farthest. What is the population being studied? So notice they don't say sample this time, they want the whole population. So I want to compare golf balls from every different manufacturer. So the population would be all the golf balls made by the manufacturers. Okay, so again, I want to stress the difference between sample and population. Population is including all of them, where again, sample is just a portion of them. Let me give you another example. If we wanted to know who the most valuable player on this year's Hamburg football team was, then this year's Hamburg players would make up the population. So if I only wanted the MVP on our own high school team, I would just look at our own high school, and that would be all of them, so that would be the population. However, if I wanted to know the MVP of the entire league, maybe all of Section 6, then this year's Hamburg players would be just a sample of the entire league. So let me pose this question. Why in example 1 would we want a sample of the fish in Lake Lucerne instead of the entire population? Well, hopefully you're saying something to the effect like it would be impossible to measure every length and weight of a fish in a lake. That's just absurd. There's no possible way you could catch every single fish in this entire lake. So again, that's why we would use a sample instead. So in our next little set, our question is it a population or a sample? Now I would say there's a lot of ways you could go on some of these questions, but as long as you can back it up, we'll probably be on your side here. So if people are asked how they voted in the exit poll, is this a population or a sample? Well, again, I think it could go two different ways. And here's how I looked at it. If you were to ask all the people that voted, then that would make up a population. However, if you just randomly ask some of the people that voted, then I would say that would be a sample. So again, I think it could go either way, just make sure you can back it up. The second one, some cars on the lot of a local car dealer, population or sample. Well, notice that it says some cars, so that's not all the cars on the lot. Since it only says some cars, I'm going to go with sample. Maybe I only looked at two-door cars or SUVs, but I'm just looking at some of them as the key to me. The words of the Gettysburg Address. Well, it sounds like when they say the words, I'm looking at the entire population. I am looking at the whole thing. So I'm going to go with a population. And maybe they're looking at the number of words in the Gettysburg Address. I'm not really sure where they're headed with that, but I think by them saying the words, they're talking about the population. The next one, the colors of pencils available in a 36-count pack of colored pencils. Again, since the package was 36 count and I'm looking at all of them, I would consider this a population again. My population would make up the 36 of the colored pencils, since that is the whole packet. Next one, students from your school who attend your school's soccer game yesterday. So again, I think I could go two ways on this. I would say population if the entire student body went. So if the entire student body went to the game, I would say that would make up the population. However, it would be a sample if only some of the student body went. Okay, so hopefully that kind of helps you distinguish between population and sample. Now here's the key. We need to have this written down. In order to get a representative sample, we need to make sure everyone in the population has the same chance of getting into the sample. Okay, so it's only going to be a representative sample if everyone has the same opportunity to get into the sample. This is called random selection. And random selection is a formal process that must be followed. And to do that, we're going to use something called a random digit table. So please do not copy this down. This is considered a table of random digits. Okay, again, please do not copy this down. We will give it to you, or we will give you a line of it to use in class. But here's how it works. Let's say there are 300 students in the junior class. Everybody in the junior class is going to get signed a 3-digit number. Well, why do I need it to be 3 digits? Well, 300 is a 3-digit number, so to include everyone, I need 3 digits. So the first person will be represented by 001, the second person 002, the third person 003, up until 300. So let's say I want to randomly pick 5 students. Okay, now believe it or not, if you were just to ask pick 5 numbers, there's kind of a bias in there. Everybody kind of has a number in mind or a favorite number. Maybe your favorite number is 2, so you might pick 2, 22, 32, 52. You have a bias to that number. This random digit table takes that out completely. So here's how it works. You can start anywhere on the table. For example, I'm going to start on, I don't know, the 22nd row. Okay, so I'm going to pull up my table. I'm going to make it a little bigger, and I'm going to start on row 22 here. And I'm going to just kind of circle every 3 digits. If that represents a student, I'm going to choose that student. If it doesn't, I'm just going to cross it off and move on to the next 3 digits. So watch, we're going to circle 814. Does anybody have 814 assigned to them? Well, heck no. I'm going from 001 to 300. So basically, I'm just going to kill those 3 numbers. Then I'm going to circle the next 3, 646. Nobody has that number. Kill that. 828. Nobody has that. 955. No one has that. 296. There is the first student I'm going to pick. So let's write it off to the side. Whoever is student 296. Then I go to the next one, 253. That falls in my table. I'm going to pick that student as well. Now I'm going to loop around. 03, and I'm going to grab this first number. So 034. Whoever has that number, I'm going to grab. 119. 1, 2, 3, 4, and I need one more. 707, that gets rejected. 290. So now I have 5 students who were randomly selected. There is no bias in there whatsoever. And remember, you could have started on any row, any place. But these are the 5 that were randomly selected. Now, what happens if this would have been 296 again? Well, you just cross it off and you go on to the next 3. You can't pick the same student twice. But this guarantees random selection. So again, there's no procedure that guarantees a representative sample, but the best procedure to get one is one that gives every different possible sample an equal chance, and that's what this random number table does. So suppose I want to randomly select 60 students from a group of 625. Here's the question they gave us from the sample. Explain how you would use a random number table or calculator with a random number generator to generate 60 different numbers at random, and include students with these numbers in the sample. So we have to be able to explain this, and this is what they think they'll give us. They're going to give us a line from the random number table. And basically, you need to say, if I need 625 employees, we're going to assign, so go ahead and let's get your random number in your table, that line, and then we'll write our workout here. We're going to assign every employee a digit, a 3-digit number, starting at 001 all the way until 625. Okay, and now we want to show that we know how to use this table. So we're going to, again, because it's a 3-digit number, we're going to start in groups of 3. So I'm going to start at 545. That is my first one. And then 880 is going to get rejected. So, 808 is going to get rejected, okay, because that's outside. Then I'm going to go with 150. Then 727 is going to get rejected. Then I'm going to grab 102. Now I've got 545. Now look, 545 popped up, and I've already used that, so that ends up getting rejected. Now I've got 375, 589, 433, 006. Let's see, 042. 299, and 182. And that's as far as they show me, so that's all I'm going to show them back. Okay, but again, this guarantees that there is a random selection, and all of these 625 employees had an equal chance of being selected. Okay, so our next little title is Population Characteristics and Sample Statistics. So a population characteristic is a summary measure calculated using all the individuals in a population. For example, the population mean is a population characteristic. Notice I'm finding the population mean. A sample statistic is a summary measure calculated from a random sample. For example, a sample mean. So a sample statistic would be more of a sample mean. So again, the big difference, population includes everybody, and a sample is just a random group from the population. Okay, so now we're going to start doing a lot of explaining. For the following items of interest, describe an appropriate population, a population characteristic, a sample, and a sample statistic, and explain your answer. So we need to identify 4 things for each of these. So if I said the time it takes students to run a quarter mile, I first need to describe a population. So here's what came to my mind. For the population, maybe I would pick all the students in the 11th grade. Right? That would represent my population. If I say all of them, all the students in the 11th grade, how long it takes them to run a quarter mile. Now my population characteristic, I would say something like the average time it takes for all the students to run this quarter mile. So a population is describing who they are. Now the characteristic is something like the mean, the average or the mean time it takes to run a quarter mile. Now we need to do something with a sample. So my sample might be to the effect a random selection of 11th grade students. Notice I'm using the word random. Okay, there's a random chance that this could happen to you, and it's just a part of the 11th grade class. It's not all of them. All of them makes up my population, where a selection makes up my sample. So now my sample statistic would again be like the average time it took to run a quarter mile of the sampled students. Okay, so do you see how the population characteristic deals with the whole group, and again the sample statistic deals with the sample? All right, your turn to play. National forests that contain bald eagles' nests. So try it on your own. Try to come up with a population and a sample, and a population characteristic and a sample statistic. Give yourself a few seconds, come up with something, and then we'll compare. We don't have to have the same thing. So here's what came to my mind, hopefully something similar to yours. I said the population are all the national forests in the U.S. And my population characteristic may be the proportion, or again, could you say the mean, if that helps? The mean of all national forests that contain bald eagles. My sample, notice again I'm saying random selection, because it's not the whole population, a random selection of national forests in the U.S. And my sample statistic, the proportion, or maybe you like the word mean, the mean of all sampled national forests in the U.S. that contained bald eagles. Okay, so again, we didn't have to have the same thing, but I'm just showing you what my example was. Let's try another one. Curfew time of boys compared to girls. Again, come up with a population characteristic, sample, and sample statistic. So here's what I came up with for mine. I said my population is all the boys and girls in the 11th grade. And then my population characteristic is the difference in mean curfew times of the 11th grade boys versus the 11th grade girls. So again, I'm just comparing the means. My sample, notice again I'm using the words random selection, a random selection of some boys and some girls from the 11th grade. And my sample statistic is the difference in mean curfew times of the sampled 11th grade boys and girls. So hopefully that helps you identify the difference between a population and a sample. Well, that does it for us tonight. So our main goal was really to understand the difference between population and sample and to understand how to randomly select students using that random number table that we have. So we'll have some practice tomorrow. Have a great night.